Okay, so we're looking at this video which is called Changing Rates of Change. So let's just go through, it's part of the topic on rates of change and ratio and things like that. Okay, so this one here, as soon as you've got a straight line, make sure the pen's right. Okay, so that's changing at a constant rate. Okay, whatever we're measuring, it's changing at a constant rate. So normally we have time along the bottom, and this might be measuring the height of a fluid or something like that. So it's changing at a constant rate because it's a straight line, and so we're saying this one is increasing because it's going up, increasing at a constant rate. So for instance, this container here, because the shape is consistent, as we're pouring liquid in at a constant rate, the height is going to go up at a constant rate. So if the shape is constant, then its rate of change is constant. Okay, so here's another example. Okay, ignoring the top bit, this shape is a constant shape. So if we're filling it up, it would fill up at a constant rate. And obviously if the water was coming out, it's decreasing at a constant rate. So if we had a hole in the bottom, the water would go out at a constant rate. So the shape is constant. So if it's a constant shape, it's a constant rate. Okay, so copy that down. Then do a quick sketch of the diagrams and come across. Okay, so then we're going to do some other ones. So again, this is going up, so it's increasing, but it's not going on a straight line. It's getting quicker as we get closer to the top. So it's increasing, but it's increasing at an increasing rate. And so for it to increase at increasing rates, it must mean it's getting narrower at the top of the container. So with this picture here, if I can just take off the top bit, the shape is big at the bottom, and then the shape gets narrower. So if I was pouring liquid in, it's going to start slowly, and then as it goes up, the height will get quicker and quicker if I'm pouring the liquid in. Okay, so this next one, it's increasing, but it's slowing down towards the top. So it's increasing still because it's going up, but it's increasing at a decreasing rate. And for that to happen, the container must be wider at the top, because as you're pouring the liquid in through the top, it's going to be quick at the bottom because there's not much there, and as it's going up, it's getting wider and wider, so it's going to slow down. So that glass or this container, it's narrow at the bottom and it's wider at the top. So as fluid's going in, the height is slowing down as it's increasing. So if it's narrow at the top, then it's going to get faster, and if it's wider at the top, it's going to get slower. Okay, so make yourself a note or draw yourself a picture and come across when you're ready. Okay, so these guys here are both decreasing. Okay, they're both decreasing, but what can you see is happening is in this first one, it's decreasing, but it's slowing down. So it's decreasing at a decreasing rate, so it's slowing down, whereas this one is decreasing, but it's getting quicker, so it's decreasing at an increasing rate. Okay, so we haven't got pictures because all you're doing is you're doing the same sort of containers. So for instance, if I had that wide container and the liquid was coming out from the bottom, it's going to as the fluid comes down, it's going to get quicker. Okay, it's going to be slow at the top. It's going to be slow at the top because there's a lot more fluid there than is there, so it's going to be slow. And then as it gets towards the bottom, it's going to get really quick. So actually, that one there belongs with that shape there. So it's narrow at the bottom, so it's going to get quicker at the bottom. So that shape there belongs with that one, whereas if I had the opposite, if the fluid was falling out that way, it's going to fall quicker, and then at the bottom it's going to fall slower. Okay, so hopefully I didn't confuse you on that one. So this one here, it's going to be slow at the top as the fluid's coming out, and then towards the end it's going to flow out really quickly because there's not much height left at the end. So that one there is that shape if the fluid is falling out from the bottom, and this one is going to be wider, flowing out from the bottom. Okay, so let's look at some containers and see how we go. Okay, so what's happening with these containers? If I drew them, actually I'll make it a little bit taller. Okay, so there's a change happening about there to there, and then there's that little bit there. So this shape here is constant, so to be filling up at a constant rate to there, and then it's getting narrower that way, so it's going to get quicker up to there, and then that's a constant shape, but that's going to be really a lot quicker than there. So whatever that line is there, the last section would have to be steeper than this section because it's constant. They're both constant, but this one here has bigger shape than the other one. Okay, so it's going to be straight, and then a curve, and then straight again. Okay, copy that and come across. Okay, so let's have a look at this one, some complicated shapes. Alright, I'll see if I can just move this to the side. Okay, so that's a bit better, so I can squeeze it in. So we've got some shapes. There's a shape change, maybe there, and then shape change there, and a shape change there. Okay, so, oh, there's a shape change there as well. So it's getting wider, so it's slowing down, and then it's narrowing in, so it's going to get quicker, and then it's going out, and it's going wider, so it's going to slow down again, and then it's getting narrower, so it's going to get quicker. Okay, look at this one. So we've got two sections there. Don't worry about, there's no fluid in there. So it's getting wider, so it's going to slow down. It's going to slow down that way, not that way. It's going to slow down, and then it's getting wider, so it's slowing down even more, but it's at a different rate. Okay, so that's slowing down and that's slowing down, but they're not going to be the same curve. Okay, copy and come across. Okay, I think this is our last one. Let's have a look. So nothing's happening there. So we've got a section there, a section there, and a section there. So it's getting wider, so it's slowing down to there. Then it's going in, so it's narrowing, so it's getting quicker to there. And then, ooh, actually there's a little section there. So it's, I think it's still going in actually, isn't it? So you're probably not quite the same. I'll extend it up to there. And then it's going wider, so it's slowing down. Okay, so hopefully that gives you an idea of changing rates of change. Thanks. Bye.